All right, in this problem, we're going to be looking at dosing. Specifically, we're going to be using the pounds formula when it comes to dosing with chlorine gas. Now, our traditional pounds formula is written out as pounds of whatever it is, in this case, chlorine gas, is going to be equal to the concentration times my volume or flow times my weight of water, 8.34. Now remember, the units here really matter. So we need to have our concentration in ppm, parts per million. Remember, 1 milligram per liter equals 1 part per million for this case. Our volume or flow needs to be in mg's or mgd, million gallons or million gallons per day. Weight of water stays the same, 8.34. Now, in traditional use of this problem, we're going to be given the concentration, given the volume or flow, we calculate pounds. That's not always going to be the case though. So what we're going to be looking at right here is we're actually given the fact that we dosed with 30 pounds of chlorine. We dosed a flow rate at our treatment plant of 5.6 mgd, and we want to know what should our concentration be given these parameters. So first way I'm going to look at it is kind of how we fill out the pounds formula over here. So I'm given the fact I dosed with 30 pounds. What I don't know is my concentration. I know that I dosed a flow rate of 5.6 million gallons per day, and the weight of water stays the same at 8.34. So kind of fill in what you know and then solve for what you don't know. In this case, I need to get concentration by itself. So I need to get rid of the 5.6 and the 8.34. So since we're multiplying by them, I'm going to divide by them. 5.6 times 8.34. Now remember to keep these in sort of brackets, right? We're multiplying these together to make this big number. We're going to move that over to the other side over here, 5.6 times 8.34. So make sure when I get my number here, you're able to get the same, because really where we go wrong is we're plugging it into our calculator incorrectly. So I'm going to do 30 divided by, and then in brackets, I'm going to do 5.6 times 8.34. Now, if your calculator doesn't have brackets, I'm going to show you that in just a second. I get a concentration equal to 0.64 milligrams per liter. Now, if you don't have brackets in your calculator, the way you're going to plug it in is you're going to go 30 divided by 5.6 divided by 8.34. Either way, you should get to that same answer of 0.63 or 6423, on and on and on. In this case, we're just going to round it to 0.64. Now, if you're going to use the pi for this, then you're going to draw it out like this, remembering that pounds over here, concentration, volume, or flow, and weight of water. The way we use this is we cover up what we don't have to solve for the rest, right? This is a graphical way of representing the same algebra that we did here. In this case, we're trying to find concentration, so we cover up concentration. Our formula looks like pounds divided by volume times 8.34, or flow times 8.34. Now, the new formula sheet also breaks this down nicely in that middle column when it comes to, not middle, sorry, but the end column when it comes to solutions. At the very bottom over here in this corner, it tells you milligrams per liter is equal to pounds over mg divided by 8.34, which is essentially exactly what we have written here. If I write it out just so we can see it a little bit better, milligrams per liter, right? My concentration is equal to my pounds, however much I dosed, divided by my volume or flow in million gallons times 8.34. So whether you use the formula straight up from the formula sheet, whether you do the algebra, whether you use the pi, you should all get to the same answer.